So this slide is just going to show how we are going to derive these formulas. So last year you might have tried to handle say the area of a triangle and stuff like that. And this triangle, the black triangle, does not have a right angle, but you could draw a line or the altitude and solve for the height, which does have a right angle. So you might have done these questions because then you could have used the sides to be for the Pythagorean theorem. You could definitely have done that. You just need the base and the height. That might have been like an application question you would have done in grade 9. But this year we want to deal with or still look at the relationship between the side lengths and the angles. So when you do sine law and cosine law problems, then you're going to have to use the appropriate labels for the triangle. And some of the questions yesterday had you do that, but most of the time you are going to have to do that with these questions, okay? So the vertices, the angles, we're going to use capital letters. Okay, and then it's the side across from that angle that is going to be the corresponding side, we call it. And when we label the side lengths, we use lowercase letters. So if this is labeled angle A, then across from it down here, that's side A, little a. This is angle C, across from it, little c. This is angle B, across from it is little b. And this is going to matter when you use the sine law and cosine law, which is what we're going to do in the second lesson, because what we're going to look for is how, like, the relationship between the angle and its corresponding side. We're going to look at what happens when you have, we call this an interior angle for these two sides. So depending on what you're given, then you have to choose between sine law or cosine law. Claire asked a good question. You get the formulas on the exam and on tomorrow afternoon's quest. Okay, so you just have to know how to use them. So one of the important things about using the formulas is making sure that you label the triangle correctly. And there were some of the questions on page 403 that I sort of snuck that in there yesterday. So if you did it yesterday, then it's the same thing today, okay? Just no right angle. So when you sort of force a triangle to have a right angle by drawing the altitude, then what we're going to do is, this slide, we're going to sort of derive the sine law. So we'll do B and C. So if we want to look at angle B, we'll do the two bottom ones, okay? So I'm going to do B. So this side to B is the opposite. So sine in general is opposite over hypotenuse. So the sine of angle B, opposite, I'm just going to write H. And the hypotenuse is C, little c. Try to make it little. And then the other vertice at the bottom is C, which also has opposite side H. But now its hypotenuse is B. A is trickier because it's split apart, so we're not going to look at that right now. So these two things have many variables, but one of them is common. So what's the common variable between those two ratios? Good. So let's solve for H. Okay, so here we want to solve for H or isolate H, so we're going to multiply by C. Again, little c. Trying to make it little. And then over here, we got to multiply by b. So this is good exam review. Now when you have two equations that have the same variable, we can do substitution. So one of the things with substitution is to label your equations. So let's label them. We'll call this 1 and this 2. It doesn't matter at all. I'm just trying to, remind you about substitution. Making the equations equal to the same variable. So when you do substitution, just as an aside, you don't have to make your equations y equals mx plus b, but you certainly can. And then the equations are equal to the same thing, and you can set them equal to each other. So you can certainly do that. So this has the beginnings of looking like the sine law. So we have sine is the only ratio now. That's why we call it the sine law, okay? And then so when we do cosine law, it's going to have the ratio, the primary ratio cos in it. And so what we do with the sine law, you are looking at the relationship between the angle and what we call its corresponding side. So what you'll see some students do is this. Once you label your triangle, students will make sort of bubbles like this. Because angle B and side B go together. If you want to pick a different color, you can. Angle C and side C go together. Angle A and side A go together. So if it's hard for you to visualize what the angle and its corresponding side are, then these bubbles will sometimes be helpful, okay? So what I want to do is rearrange this formula so that the sides and its corresponding angles are together. So here we have side C, here we have side B, but they're right now on the same side of the equal sign with angle C. So let's put them together. So I want C to be on this side with side C, so I'm going to divide by C. And now they cancel out there. Okay? But now I have B with C. I don't want that. I want B to be with B. But this time, this is multiplied, so we have to divide. Again, it's hard in English. Try to make this little c littler than the big C you've used to emphasize that it's the side. And now this is a form of the sine law. So you're going to use the sine button on your calculator, the sine ratio with an angle, and then it is in the same proportion on the same side of the equal sign with its corresponding side length. here we only focused on B and C, but we can include the other side as well. So the sine law is side A over the length of side A over sine angle A equals the length of side B over sine B, the length of side C over sine C. So it's important when you plug stuff in that you use in the same ratio the side length and its corresponding angle. So that's where, again, the bubbles can be helpful. Oh, ah. So in math, if you choose to, you can flip an equation. So I can write sine A in the top, like this one, but you have to do it for them all. So in grade 10, when you first learn about this sine law, we call this, we use this if you're finding a side length, and we use this version if you're finding an angle. But once you get used to this and you're not so troubled by having a variable in the bottom, then what you'll see is when you get to grade 11 and you use this, these are both the same thing. It depends what you're looking for. You can put that in the top of your ratio, and that makes the math a little bit easier. So if you remember yesterday when we had questions like this one, and the x was in the bottom, then you had that extra step. So using the different forms of this equation, so if you're looking for a side length, choosing to put the sides in the top, and if you're looking for an angle, putting the angles in the top will prevent this kind of thing, okay? But as you do a bunch of these questions, you might notice, I don't really need to flip it around, I can do the math. So you you might build your comfort level with this. Generally speaking, when we do, whether it's a word problem or if the question just says solve the triangle, then you should try to use the sine law first, okay? It's a little bit easier, a little bit more straightforward than the cosine law, but you need to have one full ratio. So some questions, you're going to ignore one of them, depending on what you're given. You don't have to have all three filled in. If the question says solve, or like our example that we're going to do, we're going to look for two side lengths. So what we're going to do is we're going to sort of split it apart into and fill in what you know. So you can split part of the sine law and only use two of the ratios. You can totally do that. But you have to make sure you have at least one complete one. So in order to use the sine law, you have to know one angle and its corresponding side. Sometimes the questions they'll give you side B, but then they'll give you angle A and angle C, and it will be like, well, what do I do now? So sometimes you'll have to use the interior angle relationship, and so you do 180 minus these two to get that one. So there might be you think you don't have enough information, when in actuality you do. So always try to look and see, can I do the sine law first, okay? So what I'm going to do with this question, I'm going to write down the steps I'm going to do, and then I'm going to do the math. So later on when you go back and look, then you are able to maybe figure out what I did. And then the second example, I won't do that. We'll just do the math like you would do for the homework, okay? So number one, first and foremost, you have to label the triangle. And you might say, well, Ms. Todd, it does say ABC. Those A, B, C, the capital letters, that's only the angles. So you have to label all sides and all angles. and it's a huge deal. So you need to label that this side is B. Where's its corresponding side? Over here. A, A. C, try to make a little of C. So again, it really doesn't matter if you choose to use the side length form of the sine law or the angle form of the sine law. There just might be a little bit of extra step math you have to do. But for this, because it does say to find the sides A and B, then I'll use the side length version. That was terrible. Okay, so when you have the sine law, this goes in alphabetical order. We went A, B, C, because as long as you have this right, the side length with its corresponding angle, does it really matter if I put B here, C, A? No, they're all equal to each other. If you get a question in the textbook and it's done X, Y, Z, does that matter? No. You just have to make sure that you label the angles with their corresponding side correctly. That really is what matters the most here, okay? So now we're going to fill in what we know. Or what we're given. Oh, I feel like there's a little bit of a typo here. Yeah. And if you just write 9, if you don't write 9.0, that's okay. It would have to be given. It's just not on the note. Sorry. Pardon? 9's fine. Yep. So again, it's hard for you to see that side A goes with 45, then draw the bubbles in if you want. So then a bubble is a ratio. So A goes with angle 45, B goes with angle 65, C, which is 9, goes with angle 70. So you have to have at least one filled in ratio. So you have to know one side and its corresponding angle. So now that you have this, we're going to find side A and B. What I would do is split it apart, okay? So we're going to use the ratio that we know to solve for side B, and we're going to use the ratio that we know, to solve for side A. So again, there's a variety of ways you can do this. I'll just write it with a dotted line here. So sometimes the question will only ask you for one side, and then you can just split it apart. So if the question just said find side A, then I wouldn't even need this over here. We could just ignore the B completely. So this question is more like one where you have to solve for all side lengths and all angles. Yes. Yes. Is that better? Because we need one complete ratio to solve for this. It is possible to just use this form and manipulate, but especially when you're first getting used to this, then it just makes more sense to split it apart. With the sine law, we eventually want the ratio between the side length and the corresponding angle to all be equal. So we want all of these to be equal to each other anyways, okay? So now again, you have a variety of ways to solve this. So yesterday, when you solved the trig ratios, if you preferred to change this into a number, you can do that. You can do 9 divided by sine 70 in your calculator. You can do do this first, sine 70, whatever that is, write it down, and then do 9 divided by that number. So it really depends on the relationship you have with your calculator, okay? So, and really, actually, you could do it all as one step. 9 divided by sine 70 times sine 45, that's how we're going to get to A. So once you're comfortable with this relationship, there are definitely shortcuts you can take. However, if you are not sure or you don't have a good relationship with your calculator, I don't recommend that you try to take shortcuts because you're just going to make mistakes. And if you show me less work and you don't get the right answer, then it's harder for me to give you part marks because I don't know where you went wrong, okay? I don't know what you got right and what you actually got wrong. Wherever you want. Actually, before we even do the math, what should we do with our calculator? Yes, check that it's in degrees. So D, DEG, DRG, because it's really your calculator, if it accidentally got pushed, it's easy to switch to grad or grad, okay? So you want to make sure about that first. Okay, so I did 9 divided by sine 70. Now to get the sine 45 out of the bottom, what do? Multiply. So again, if I'm just gonna leave it as sine 45. But if you don't like that, then type this in your calculator because this is a number. Sine 45 is a number. You can do that too. Just like we did yesterday, okay? And maybe you're even used to clearing every time you do a math function. So even if I did 9 divided by sine 70, if you just leave that and then just put your calculator down and then write down, okay, I gotta multiply now by sine 45. Then you can go to your calculator times sine 45, okay, and you've pushed less buttons. So you can do that as well. Does it say 1 decimal place? Yes, it does. Okay. And it doesn't say centimeters, so I don't have to put a unit. Yes. Okay, what you might have to do is 9 divided by sine 70, push equals, and then do times sine 45. Try that. Did that work? Yep. Yeah, so if you want to change sine 45 into a number, that's fine. You can do that. This was 9 divided by sine 70, not sine 45. For sure. Yep. You know what I'll do over here? I'll try to squish it in. There's a little bit more space over here. I'll do this side where I change them into numbers first. Okay? So those of you that like that, I can do that too. You can do that too. Okay? So I got rid of the signs, I got rid of the letters. Sorry. Let's just squish. So here I did sine 65 and I had to round. That's fine. I did not sine 70. I had to round. That's fine. 9 divided by this should give you the same thing over here, but then you can check your math and see if it did. Sure did. Then the sine 65 or 0.9063 was in the bottom, so I had to multiply. Unfortunately, I didn't want to squish, or I had to squish, sorry, so it's multiply over here, and you should get 8.7. Unfortunately, when you do these questions, you can't, like say you were doing the hypotenuse yesterday, then it would have been the longest side. That doesn't work here because we don't have a hypotenuse. So I would do 9 divided by 0.9, and then write that down. And then this is in the bottom, so then you're going to multiply 0.7 to get it out of the bottom. You can do the same thing like we did yesterday to make sure if the question does say solve and you want to make sure that you actually did solve. So fill in what you found out. So now all of the side lengths and all of the sides have been solved for. Hopefully you're faster at this. Really, this isn't a long question, eventually. Cosine law is a bit trickier, and so are the word problems. Okay? So this time, we are asked to find angles. So we're going to use the form in the sine law with angles on top, but like I said, it really doesn't matter, okay? So this time, I'm not going to write the steps out like I did last time, so this would be more like what you could do for homework. But you have to, right now, all that's labeled is the vertices or the angles. You have to go in and label the sides. So 23 is across from A, and then 16 is across from B, and we don't know side C. So now you have a choice. So which ratio is filled in? A, B, or C? B. So we're going to definitely need sine B over B. And then we have to do angle A and angle C. So you can do the same thing like we did. You can plug in everything that you know, or you can go right in and pick an angle and use the sine B side, because we can't do A and C at the same time. When we do this, once we find one of the angles, then you have a choice. You can do 180 minus the two angles we have and find the other angle, or you can do the sine law twice. Okay, so you should get the same answer. It really doesn't matter what you do, and either way would get you full marks. Okay, so we definitely have to use B. It's the only one we know, but A and C we don't. So I will write it filled in, but you could definitely just go right into splitting it into the two ratios that we don't know. And this might be helpful to, again, emphasize what do we know and what do we not know? Yes. So that because we're looking for an angle, so I put angles on top. But you don't have to do that. You can do it the other way, but then you're going to have an extra step like this, okay? Where your variable is going to be in the bottom. So it actually does not matter. So we can't do anything with C yet, so let's just do A and B, okay? Okay, so again, decide. Do you want to change sine 36 into a number? You can do this all as one step. It's really up to you. Probably what most of you are going to eventually do, sine 36 divided by 16. But again, you have to be careful, because if your calculator does not use brackets, then you have to push sine 36 and equals. You don't want it to do sine 36 or sine of 36 divided by 16. You want sine 36 and then divide by 16, right? So be careful and get to know what your calculator is like. So if it makes more sense to you, then do what this is. Like change sine 36 first and then do the dividing. If that makes more sense to you, then again, show more at work so that you don't make annoying mistakes, okay? So 23 is in the bottom. We're going to multiply. And there are definitely many of you that eventually will be like, you know what, I'm going to do this all as one step. Sine 36 equals, divide by 16 equals, times 23 equals. And that's totally fine, okay? Now, this does not look like a normal angle amount, yes? So don't forget that this is not, A is not isolated yet. So how do we get rid of the sine? Sine inverse. This one? Sort of, but it's a special button on your calculator. So as long as you know what the special button is, then you're good. Does it say 1 decimal place? No, it doesn't matter. So I'll just do 1. Sometimes angles will be to the nearest whole number. It really just depends on what the question says. Sure. Sure. Oh, sorry. You're right. Okay, so now, so don't make more work for yourself. We don't need to solve for side C or anything like that. Let's just go and find angle C. Okay?